multiplying, dividing rationals, level 1. So here is my problem. Again, this is going to be a problem that I'm going to need to write out some work for. So I'm going to do that on my paper here. So first thing I'm going to do is copy down the problem. X squared minus 5x minus 36 over 8x plus 32 times x minus 7 on top. And on the bottom, x squared minus 16x plus 63. So there's two different problem types here, multiplication and division. This first one is multiplication, so this is a little easier. Basically, what we're going to do is factor every piece here. Make sure all 4 of these are factored. And then for multiplication, we're just going to put it on one big division bar. So the first thing I'm going to factor is this here, x squared minus 5x minus 36. There's no number in front of the x, so I'm just going to add a 1. Now, since that first number a is a 1, this is going to be one of those easy questions to factor. So over here, my diamond, I'm looking for something that multiplies to negative 36, and that adds to negative 5. So I'm going to list out what multiplies to negative 36. I could have negative 1 and 36. I can have 1 and negative 36. Negative 2 and 18. 2 and negative 18. Oh, you guys can't see that. Um, 3 and negative 12. Negative 3 and 12. And then 4 and 9, or negative 4 and 9. And that is the entire list. Now I need something that's going to add to negative 5. So you can go through and add each of these until you find the right one, which would be this pair right here. Positive 4 and negative 9. So I'm going to replace this part here is its factored form, x plus 4 and x minus 9. Now the next piece I'm going to look at here is the top of the second fraction, x minus 7. There's nothing there that can be factored, so you just bring it down as x minus 7. Now I'm going to look at this part here, 8x plus 32. There's no x squared in that piece, so I don't need to factor like I did here. All I need to think is what can 8 and 32 both be divided by? Those can both be divided by 8. So I take an 8 out. 8x divided by 8 is x. 32 divided by 8 is, think for a second, 4. Now I'm going to look at the bottom of the second fraction. This has an x squared term, so I'm going to have to factor like I did here. There's no value in front of the x squared, so I know it's a 1, which is good. It makes it the easy type of factoring problem for us. So here's my diamond. I need something that multiplies to 63 and that adds to negative 16. So I'm going to list out all my pairs. 1 and 63. 2 doesn't work. 63 divided by 3. So then we can have 3 and 21. 7 and 9 is the next pair. And that is actually all of the pairs. In order for it to multiply to a positive, add to a negative, both numbers in the pair has to be negative. And to add to negative 16, I want negative 7 and negative 9. So I can rewrite this bottom down here in the factored form, x minus 7, x minus 9. Now, similar to the first skill, once you have it factored, you just look to see, is there anything that is the same on the top as it is on the bottom? So I have an x plus 4 on top and bottom. Those cancel. I have an x minus 9 on top and bottom, and I have an x minus 7 on top and bottom. So on the top, there's nothing left, so I can put a 1, and the bottom, all that is left is the 8. So then you can type this in your Delta Math page. Again, backspace key will get you a fraction, so 1 over 8. And I want to submit, and there's how you do multiplication. Now this skill is going to switch between multiplication and division. So let me get to a division problem. So here is what a division problem might look like for you. There it is. Division is going to work in pretty much the same way as the multiplication problem. There's just going to be one step at the beginning that is different. So first thing I'm going to do is write down the problem. X squared minus 49 over x to the 4th plus 7x cubed. Now this time it's division. X squared minus x minus 42, and then on the top is 3x. Now, the one item or one step that makes division different is that when you start it, you need to keep, change, and flip. This is how you start a division problem. So what the keep, change, flip means is I keep the first fraction exactly as is. So x squared minus 49 over x to the 4th plus 7x to the 3rd. So I don't do anything to the first fraction. Then I change the division symbol to multiplication, and then I flip the second fraction. So this whole fraction here gets flipped. So on the top, I put the 3x, and on the bottom is x squared minus x minus 42. Now, this problem is exactly like the one that we just did. You treat it like a multiplication problem. So you're gonna factor each piece and write it on one big fraction bar. So very first thing I need to do is factor the top of the first fraction, x squared minus 49. Now that one does look a little strange. So I have x squared, and then normally there's an x term in the middle that I'm missing. So I'm gonna add in plus 0x minus 49. I'm just adding in that term that's normally there as a 0. And in the front, I can add a 1. So this has an x squared, so I know I'm going to need to factor with that diamond. Label A, B, and C. So in my diamond, the top is negative 49. So I'm looking for something that multiplies to negative 49 and that adds to 0. So my options for multiplying to 49 are 1 and 49, where either the 1 can be negative or the 49 could be negative. And then the other option is 7 times 7, where one of them is negative. So the only pair here that adds to 0 is negative 7 and positive 7. So on the top, this first part here becomes factors x minus 7, x plus 7. Now we're going to look at the, we might as well just bring the top of the second fraction over. There's nothing that can be done with that, so I'm just going to leave it as a 3 and then put the x in parentheses to keep everything the same. Now I look down here, x to the 4th plus 7x to the 3rd. Now that one we're not going to factor with a diamond because it's a 4 there, not a 2. What we need to figure out is what do both of these terms have in common? Well, they both have an x to the 3rd in common. So I'm going to divide by an x to the 3rd. So x to the 4th divided by x to the 3rd leaves 1x on the inside. 7x to the 3rd divided by x to the 3rd leaves a positive 7 on the inside. Now the last piece we need to factor is the bottom of the second fraction. I'm going to add in my 1s there since there's no number. Label A, B, and C because it has an x squared term. So I know I'm going to use the diamond to factor. So I need something that multiplies to negative 42 and that adds to -1. So 1 and 42. You may not need to list out this entire step. You might be able to see which pair is going to work. -21. And then what else do we have? 2 and -21, so 40. And then we could do 3 and 14. And then our last pair is 6 and 7, where either the 6 could be negative or the 7. Now we check all of these. The only pair that will add to -1 is +6 and -7. So I can replace the bottom of this with x plus 6 times x minus 7. Now we look to see what is common on top and on bottom. So first thing I see is x minus 7, x plus 7. And now what's a little tricky here is I have just a singular x on top. So that can cross off with one of these x's. So this x will cross off with one of these to make it x squared. So on the top we're left with a 3. On the bottom we have x squared. And we're also left with an x plus 6. And then we can type our answer in Delta Math. So 3 x squared plus 6. And I typed my answer in. You can see that it is correct. That is multiplying and dividing rationals.